They had me present quite early for my previous talk in the main session, and so if you missed it, I will just kind of go over briefly what I covered there, because it's still helpful for this, what we're doing here. So, just briefly, in a verifiable credential realm, we have, in the physical world, right, you have an issuer of a credential, someone who holds it, and then someone who verifies it, and you have to verify it somehow. So these are different ways you can do it in the physical realm, but the main thing you're checking for is that the credential has not changed since the issuer gave it to you, and it hasn't been revoked. Am I supposed to wait? Oh, this might help. Does this help at all? Or do you prefer without the microphone? Oh, either one is fine? Well, this will save my voice. Okay, so in a nutshell, that's how it is. That's the architecture you got to keep in mind as you're developing for credentials, because you'll kind of see different code that's segregated between an issuer and what that issuer does, what a holder does, and what a verifier does. Now, in development, these roles are not mutually exclusive. Like, for example, as a person, I might choose to issue credentials about myself, or I might attest to somebody else's credentials. Anyway, issuers are also verifiers, verifiers are also holders, and so on. So keep in mind these are not exclusive, but that's kind of the roles we typically think of things. So with Sovereign and Indy, and what you're going to be seeing is it enables all of this to happen, and we're going to be writing stuff to the Sovereign ledger, or like a demo ledger, and then as a holder, they'll be reading information off of there, and same with the verifier, and there's going to be some interaction between them and how that all works. And then eventually, we're going to realize, hey, we don't have to show absolutely everything. We can just strip it down and just show exactly what's necessary and nothing else, which is really cool, because now the bartender doesn't have to know where I live if he has a photographic memory. He might remember where I live, he might remember when I was born and my name, when all he cares about is, can I buy the drink and am I old enough? That's it. So one thing you have to keep in mind is with verifiable credential development, we're going to be covering zero knowledge proofs. Now thankfully you're not going to be implementing any of this crypto, it's already been done for you. All you have to know is what parts to call in the functions that we'll be doing. And so if you don't know what a zero knowledge proof is, it's a way to prove something to a verifier such that he is convinced and you can't cheat, and the only thing he learns is what the statement was proved. Think of it as like a predicate function. It returns true or false, you pass in inputs. Is that true? Yes or no. That's all they do. So that's pretty cool. So with Indy, there's actually two pieces of the code that you may be interested in. The most common one people care about is this one, is the SDK. They want to wrap the cryptographic functions that talk to the blockchain or that interact and make proofs, that kind of stuff. That's where that code is. I'm not going to have you dive into that just yet. But just keep in mind that if you ever want to do any blockchain development, because Indy can't do what you want, but you want to add it, this is where you would add it, is what we call Indy node. An Indy node is the blockchain code, and it has a pluggable consensus algorithm, so if you don't like what we're doing, which is our BFT right now, you can pick your own. Okay, so when you are developing for Indy and you want to become a brand new issuer, I want to issue credentials, you have to create what's called a DID. So if you want to know what a DID is, Mike Herman's right here, and he'll answer all of your DID questions, whether he did it or not. So this is how people will know who the issuer is. Now, the other thing is, what type of credential are you going to be issuing? That's what the schema is defining, is what attributes are you going to be attesting when you're an issuer? Is it names? Is it birthplaces? Is it a location, merchandise I've sold, whatever the case may be. And then you need to know how those attributes are encoded. So Date of birth by itself doesn't mean much, right? Is it 1/1/ a year, 2 days, a month, and a year? Or is it a Unix timestamp? Is it number of days since something else? So you need to figure out what type of encoding that is. And once you've done that, then you need to pick, or then you need it to generate a key. Oh, that's going to be dangerous. You need to put your key on the blockchain so that people can validate these credentials. And then if you want to do revocation, it's optional with Indy. You create a revocation registry. Now this is all taken care of you by the functions that are there. And we're not going to worry about presentation descriptions, but think of those as what information do I want proved to me or to prove to somebody else. You can actually create your own, but those don't have to be on the blockchain, but they can be if you want. So Aries, for example, is where most people like to spend their time because Indy's develop most of the work for you. And Aries is where people wrap this toolkit and develop what we call wallets. And an identity wallet is a wallet that receives credentials, holds credentials, and does proofs with them. And we realize this is quite an agnostic feature to Indy, therefore we open sourced it as Aries. So Aries handles any blockchain you want. You have to plug that in yourself. I'm not going to worry about doing that here, but I'll show you where that kind of stub is. It's supposed to handle wallets, or kind of the data storage layer, protecting your keys, rotating keys, anything under the hood that most users don't really know about. Any DIDs that might be created. So remember in Sovereign we create a DID for every person or party you're interacting with. And then any messages you may want to send to them, like hello, or here's a proof, I need this credential. The code, if you want to take a look at it, this is where a lot of that lives right now. So when you put them both together, it's specifically designed for just the credentials for the most part. Composite proofs are interesting. This is where I might have 5 credentials, but I might need to prove something from each one of them or a subset of them, more than just one. That's what a composite proof is. I can create a whole bunch of different types of proofs, which is pretty cool. All right, so Ursa, if you are very interested in the crypto layer and you want to add something that doesn't exist yet, that's where you would do it. That's where all of the heavy lifting for the zero knowledge proofs exists. And this way it's also shared among other Hyperledger projects. So Aroha just adopted Ursa. Indy obviously donated it, and Sawtooth is in the midst of integrating Ursa as we speak. So if you don't want to talk to the Indy blockchain, but you want to talk to others, you can still use the same cryptography that was implemented for all of them. So anyway, you have to keep in mind that when you're writing your own crypto, there's a lot of problems that can happen. So developing your own stuff, the reason we wrote all these toolkits is because, one, it's bad to just roll your own everything, but it's especially bad for crypto. There's so many bugs and issues that can happen if you try to write your own. So don't do it unless you really know what you're doing. Okay, so just real quick, if you do want to contribute to Ursa or start taking a look at it, it actually has 2 parts. And these have all been reviewed by people with PhDs in cryptography and some other hardcore crypto engineers. So libUrsa is your primitive basics of encryption, hashing, signatures, key exchange, and coming forth any hardware integration you may want to add, like Intel SGX enclaves, Apple iPhone secure enclaves, those kinds of OS key rings. Pretty cool. And then the ZMix is designed to be all of your zero knowledge proof stuff baked in a box. You just describe what proofs you want and it'll pop out the proof. You hand that to the verifier, throw it back in ZMix and say, please verify this, and it does it. That's the goal with it. So you have to keep in mind when you're doing zero knowledge proofs that you don't reveal too much information. So as a verifier, you might say, prove you're over 21, now prove you're less than 23. Well, so you didn't really hide your age if you agreed to answer both of those. So keep that in mind as you're designing the zero knowledge proofs you want to collect, that it doesn't become this game of 20 questions that the holder's just going to keep agreeing to, because then you're not really hiding anything. So this is what you can do today with URSA. You can check for equalities and say, I want you to prove that this attribute is a 1 or a 2, or your name is Mike, and it will say yes or no. So the great thing is, if my name really is Mike, then they've learned my first name, but if it's not, they didn't learn what my first name was. Inequality is, that your name is not this, or you are not, it's not equal to this, or you can do a ranges, where you can say, I want greater than, I want less than, greater than or equal to, do both. Set membership is, I have a fixed set of values, and I want to prove that one of my attributes is one of those, but without revealing which one. Or the reverse is true, it's not one of those. That's the less common one, but it does happen. So when we talk about revocation registries, we're usually talking about, is it in the set? So think of, here's a set of issued attribute numbers. It's one of these 10 million. Good luck figuring out which one it is. And then the rest of them stay hidden. That's the whole point of selective disclosure. We're not going to go into those for this, but just keep that in mind, that if you ever want to do ZKPs for other things, these are some other possibilities you could implement with those. We're not going to for the sake of this class, because it could get quite interesting trying to do that. So, all right, so I want all of you to open up this first one. It's called the Aries Cloud Agent Python. That's the link on it, and then start following along. So the British Columbia government created what's called the Vaughan, the org book. They basically took Sovereign, issued a whole bunch of business credentials, and it's an open, and this is all public information anyway, and they issued verifiable credentials with this. So if we go to this link, let's see if it'll open for me. Maybe, maybe not. Come on. And it opened on my separate screen, that's why. Let's see. So there are several demos in here, and what we did was we set this up so that all of you can try this out to kind of get a feel of how all of this works. So this completely runs in your browser. You don't need to install anything unless you don't have a browser. But anyway, we tried to clean up the text for you so that you can do it. And where you're going to go first is you're going to click this link that says Play with Vaughan. And when I click it, it's going to open in my other browser, isn't it? Oh, maybe not. And then what you're going to do is it's going to pop open a terminal, and there's going to be some commands for you to explore and see how this works. Let's see. Oh, now it wants me to, oh, there we go. Good. I don't have to log in. You should not have to log in. If you did, you didn't go through the link, and that's why. So if you tried to type this link in directly, it'll ask you to log in, whereas if you go through what we did, it mitigates all of that for you. Who is not able to get here that wants to get here? Is there anybody that's having any issues with it? Or is it just slow? Everybody's chewing up the bandwidth? Alrighty. Now something to keep in mind, this will expire in 4 hours. So if you try to do this over again with the same link, it will delete it, because these spin up some temporary instances for you to complete this whole process. Okay, so I've got it open. And then, let's see. The first thing it asks me to do is add a new instance. And these are full-blown Docker instances that you can run. So make sure you ignore this nice warning and put all of your personal information in there so we can steal it later. It says add a new instance, and then what this first command, which I'm going to show you, and you can follow along by running your own, is it's asking me to clone the repo for Aries. Let's see if it'll do it. Oh, yeah, there it goes. It's just going really slow. This is a real URL that any of you could hit right now. And as far as I can tell, it's not running on my local machine. Wow. I don't know if I can scroll. Oh, there we go. Okay, so this is kind of the demo that Phil was trying to do in the main session. Is Alice is going to attend Faber College, but we're going to do it with code instead of with an app. His was in an app. This is, if you want to do code, you can run all of this. And one common term you're going to see a lot is the term agent. Agents, people don't do cryptography, unless you can do it by hand, but usually you have an agent do it for you. And one of the common terms we use is if it's on your phone or if it's something that's directly in your control, we refer to that as an edge agent. It's under your direct control. And you might have a service that runs in the cloud, something that all it does is answer messages for you when you're offline because you're not always online. So we refer to that as a cloud agent. So Aries already has a cloud agent written for you, and I'm just taking advantage of it in this case. And that's why it's called the Aries Cloud Agent. It's written in Python, but there's other languages if you're more familiar with others. Let's see. Is anybody else's running as slow as mine, or is mine the only one running slow? It's just slow. I don't know if it's the internet here. Well, in the meantime, I'll show you, this is just a walkthrough of the demo, but let me go to, what's the first thing you're most interested in looking at? Is it agents? Is it Indy? Is it the crypto code? And I'll go there first and kind of start showing you how that all works. Does anyone have a preference of which one while I'm waiting for that to start? Wow. No one has a preference? Well, this is going to be a short session. What I will do then is I will show you Indy, because that's the one I'm most familiar with. And I'll start with the SDK. See if it even goes. Okay. So this is the repository if you just want to work with Indy. And there's quite a few things in here. There's the main thing you want is called libindy. Libindy talks directly to the ledger. It also does your proofs for you. We're right in the middle of moving a lot of that to Aries to make it more agnostic. But if you want to do a command line, you could do that here. You don't have to build it, or you would have to if you wanted to take a look at this, but this is the Indy CLI that will show you how to do it. But if you just want to install it or do different things, here's those instructions for running it. We're not going to do that today unless you want to. Oh, that's the link I was looking for. Michael Herman, was it this bad for you when you were doing your presentation in terms of internet speed. It seems quite slow. Let's see. Oh, it's still going. Wow. Okay. So to kind of give you a high level of libindy, this is an architecture document that's been written up. So it works similar to this. libindy is written in Rust, and so is URSA. And the reason for that was we wanted to develop a common core and only write it once and not have to rewrite it for each one of these languages. And Rust compiles to C. Therefore, anything that can wrap C will work with libindy. And we've already written some wrappers for you. So those are the wrappers that you can just use right out of the box, which is pretty cool. Now this looks a little confusing, so don't pay attention to these arrows. Just know it's divided into layers. There's what's called the API layer, which most of the time you don't have to worry about that unless you're writing something completely new. Then they have what's called a command layer. And then a service layer. Service layer is where you're actually writing the actual stuff, and then the rest of this is just kind of exposing it to the outside world. Because everything in libindy runs asynchronously, at least it does for now. That's changing a little bit, because a lot of people found it confusing. But the point is, when you're talking to a distributed ledger, you end up waiting a long time, because you have to talk to a lot of nodes to get the correct information back, or when you write something you have to wait for it to come to consensus, and it can take a long time to do that. So to mitigate that, that's why everything was written asynchronous, because you're just waiting. There's not a lot of intense operations. It's submit this and wait for, a couple of seconds for it to come back. So as you look at the code, just keep this in mind, that that's how they've divided things. So let me show you a little bit of that. And you're welcome to keep browsing libindy as we speak on your own here. So if we go into libindy, you will see kind of those three layers. Once I click source, there's the API, there's the commands, and there's the services. The rest of these are just kind of helpers. But if you look at this, this is how they expose it to C and the different areas. This is obviously where I do my credential work for proofs. If I want to talk to the ledger, here's all the ledger commands, and the rest of these are wallets. And if you want to do a DID, these are some crypto functions and caching and all sorts of interesting things. But that's where all of the code lives. Now, if you're interested in skipping that and just going straight to an area above it, there's a library called VCX, or Verifiable Credential Exchange, that wraps a lot of that libindy stuff for you and abstracts it away. This is the code that's mostly going to Aries. And this is where you can write code that will issue credentials, create requests, write stuff to the ledger, and abstract a lot of that away for you. Okay, let's see if this is done yet. Still going. Oh boy, my Wi-Fi's out, no wonder. Oh, maybe not. Anybody else having Wi-Fi issues? Yeah. You have the same error? And you're on MiFi? Oh. Oh, so I wonder if it's their server. Wonder if I hit refresh. Oh, no. I'll stay. Oh. There we go. Context canceled? What? No. I was worried about this. Why would it reset it? Is anybody else's going through successfully? Yours going just fine? Okay. I'll go ahead and just stop mine, but the point is, what you're doing is you're walking through, and in this case you're basically creating an agent for Alice, and then Alice will interact with that agent to do different things. So you create Alice's cloud agent, and then this is an agent for Faber College. Remember, we talked through agents. So we're creating an agent for the college, and then we're creating an agent for Alice in this case. So in Phil's demo that he was doing this morning, a lot of that was handled with just clicks. So here we're doing it a little more programmatically by just cloning repos and running the code that executes this. The great thing is, since this is GitHub, you can just go look at the code yourself and modify it for your specific needs. Okay? And then it says follow this, and if you need to run it locally and all that. So we'll skip all of that because you don't want to do that. Where did that go? Okay. So Faber can do these 4 things. It can just terminate, or it can say, I'm going to create a new credential, or I can create a new connection, or I can send a proof. Alice can do a few more things, like she can accept the invitation and send a message back. I wish I could bring this up so you could see the agents talking to each other. Now here's the interesting thing about agents. You may say, well, I have WhatsApp, I have Signal, I have iMessage, right? But the difference here is agents, when they communicate, there is no centralized server. I created my own cloud agent wherever I wanted, or I might hire someone to do it for me. It's like your internet service provider. They can come and go at any point. You can fire them because they're not doing the correct job for you. They're too slow, or some may offer better services than others. That's the cool thing about agents. This is all a decentralized system. So when you design agents, keep that in mind, that the cloud agent can live anywhere that you want, and the edge agent is supposed to live on something like this. Or it could be my laptop, or if you want the cloud and the edge agent to be the same agent, you can do that. So, but the great thing about it is all communication is encrypted and then encrypted. We've already written that. It's all implemented in the code. So are you able to keep going on yours? Yours is continuing to work? Okay. Okay. So the first thing that what this is going to do is Alice is going to request, or Faber is going to give her a credential, and then what she's going to do is she's going to go prove something to somebody else about it. So the first thing she does is she just usually proves right back to the university saying, yeah, I got it, and see, here's proof that I got it. And then if you keep going, if we dig into the code, you can go look at the scripts, and then we watched a video to understand what's going on. If you don't, I don't care to see the video, but if you want to, go ahead and start it on your own. And so the great thing is, since we set it up with this, everything's just a REST API. You can do whatever you want. The code is pretty open and doesn't care how you want to do this. All right. So now I want you all to try this challenge if we can get it going. Is now I have Acme Core, which is like a bank or something, and I want to give Alice a credential from a bank. So go ahead and take a look at it and see how it works. Is there anybody here that does not understand Python? Okay, excellent. So this should be easy for you. So you get to fill in this code and try to get it to work for that use case. So right near here we're saying create a schema for this new thing and write your own. So go ahead and do that right now if you're not going. Let's see. One great thing about Rust is usually the test code is exactly what you're looking for if you ever need to write your own. So let me show you an example of that. If you ever wanted to write this on your own. Because I get asked this quite often. Well, I want to write my own kind of credential stuff. How do I do that with your Rust code? So there's this great test called Demo that does this exact thing with raw Rust code, and it can show you how to do it. Like, here's how to create a schema, here's how to create a cred def, here's how to get a credential, here's the whole process cryptographically and how it works. And I can say I want my age greater than 18, keep going, add another proof that might say make sure that this is the same, and then verify it. Here's another test. Let's see. I think this is the money one. Yeah. So one thing to understand about the proofs is you have a credential that has selective disclosure. You're just either the attributes are revealed or not, and that's all it does. Then you attach what are called predicate proofs, where you have greater than, less than, not equal, in a set, not in a set, that kind of stuff. Those are, and then you build up a whole bunch of proofs, and those are what you present to others. So that's what this is doing. Is this assumes you have a big company spreadsheet of money, and you have to do different things about it. So let's see if I can find it. Oh, that's not it. Yeah, here we go. So I have an attribute that called cash or funds sold and securities purchased, allowance, and so on. There's a bunch of these. And then I'm going to basically create a whole bunch of proofs, whether it's greater than, less than. Right here, it's less than 100. This is greater than, less than, greater than, less than or equal, and so on. So anyway, that code is in URSA. There's also another getting started guide if you want to do any development. Am I plugged in? I'm not plugged in. No wonder my battery's almost dead. There we go. Okay. These are all various getting started guides, and so what I want you to think about is if I were an issuer for my company, what kind of credentials would my company issue? There's receipts, there's invoices, and all sorts of different things my company might do. And so these demos were written for academic, for banks, and that kind of thing with code that you can just go and modify it. And to help you understand what the interactions between them are. So Alice could issue credentials about herself. The bank could also issue credentials for KYC, for AML, for for financial stuff specific to Alice. I wonder if I should just run this myself, because I believe I've got this all done. I can't get it over. Let's see. There we go. Now, if you want, you can also start your own, like if you want to do ledger, this is mostly for ledger development, but if you want, you can also create one yourself on your local machine, an Indy pool, and it will automatically spin it up for you. I believe I've already got it going. Nope, I don't. Man, I'm having some serious issues here. No matter what I click, nothing works. Yeah. It goes through, did you get all the way to the Acme Corp? Yeah, so if you're done with that, then did you fill in the blanks and stub in for custom schema credentials that you want to issue? Uh-huh. Uh-huh. Yep, yeah, you just accept in that case. So normally when you do an invitation like on your phone, I might have a QR code and you go, oh, here, we'll scan each other's QR codes and then it'll just work. And then we connect. In this case, I'm just connecting them manually for you. That's all that Play with Vaughn is doing, is it's connecting Alice to her college. And then what you're going to do is you're going to do the same thing again for Acme Core, but you're basically taking the credential she got from Faber and using it to present to Acme, and then Acme goes, oh, okay, now that I know this, I'll issue Alice a credential. So once you've kind of got that flow down and how that all works, then, yep, it's all running on Sovereign. So I tried to make it so nobody had to install anything specific, but obviously when you're doing development, you're going to need some tools. So to get started, usually we just do it like this. You just do pip install your instructions. Let me go to Aries and kind of help point you in that direction. So you have what's called the Aries framework, and then there's the Aries cloud agent, static agent. A static agent is interesting. Think of it as like an API. It never changes. It always returns the same results, but you might want an agent that does that. It's, believe it or not, quite common, which surprised me. Anyway. So pick your library that you want to code in. Pick, if you're familiar with Rust or not familiar with Rust, then we can help you get started with that. The other thing is in, let me go back to, where is that? If you want the deep dive of Hyperledger Ursa, let me show that to you. So here's some more demos, how to get started on the demos. And let's see. Yeah. So like I said, all of the Hyperledger projects have been written in Rust. So if you want to code something directly in there, they're written in Rust, at least the common core stuff. Hopefully you're just consuming these. But if you want to add functionality, you'll have to learn Rust. It's actually quite easy. I picked it up in about a month of writing just about every day. And like I said, they expose all of their functionality through C library calls. And those have already been written for you, but let's see, yeah. Those are some other links if you want to get started with Indy on how to get going through the walkthroughs. I'm not going to go through them because they're quite lengthy, but they're mostly the Alice Faber Acme walkthroughs to kind of get you started. Plus there's code examples in there and how to get going with those. And then in URSA, those are some of the, if you're interested in the exact crypto primitives we're using, that's what we're doing. A lot of people ask, well, how do you deal with trusted setups or snarks and that kind of stuff? In fact, we're not even using snarks, so we avoid that. And in URSA, for example, there's actually two types of interfaces. We have what are called the developer-friendly, where we just make it really hard for you to screw it up and make it nice and friendly for you. But if you're more interested in the cryptography side and you're a cryptographer, there's also the crypto developer interface, so you can mix and match and do whatever you want because we hope you know what you're doing. So anyway, those are the links for all of URSA development. And this is what's currently going on. I'm focusing a lot on URSA because that's where actually I spend most of my time, is we're now developing crypto provider hardware. There's quite a few, like Dan Bonnet and some of his colleagues, and Nigel Smart are helping us develop this with their custom hardware, custom secure enclaves that they're doing, which will be really cool. And we plan to put that in there. And so I talked about Aries, and these are the projects they're starting to use everything. And so let's see if I can get the Aries Cloud Agent to even work. Kill that. Kill that. Nope. Does anybody need help doing this part right here, where you define a schema or know what a schema is or how that all works? Now, one thing you have to remember is Indy doesn't do any encodings for you. Aries does. Remember how I talked about attributes? So, for example, Indy just expects you to just pass a raw number of bytes, and that's what represents your attribute. And so you have to do all of the encoding at the Aries layer. Aries will say, oh, you want to encode it as this, therefore I'll change it so that it matches what you expect. But for a schema, you don't have to worry about that, but you have to know that, oh, like for example, a date, what does a date look like? Is it a number? Is it an ISO 8601 number? Is it a different thing? You got to think about that. Now, on Sovereign, there's already some predefined schemas, and I wonder if I can bring it up. It's called Indy Scan. Let's see if I can find it. Oh, I spelled it wrong. I think that's what it is. So if you ever want to see what's already on Indy, you can go take a look at this. This is a free tool. It'll tell you how many nodes there are. It'll tell you different types of transactions. Man, this needs to, oh, that didn't help at all. Now, Sovereign actually has 3 different networks. There's the main net, similar to Ethereum, a test net, which is periodically blown away, and it's where we do a lot of our deploy for live tests. So, and then there's the builder net, which is where you can play around with stuff and not worrying about it being permanent. Like, we had a developer that submitted his face as a transaction. Anyway, so now he's permanently known. That's what he put in his did doc. So you can take a look at the different things. Let's see, come on, where's the one that I want? Okay, so on the domain ledger, this is the main one that we always care about. You can say, show me all of the transactions that had a schema written to the ledger. And so I can check this and filter it. Let's see, is it going? Can't get anything to work here. A NIM is a DID. That's just what they called it at the time. If you want to see any revocation registry changes, this will filter it, and it'll show you exactly what was written and when. A TRIB is like metadata about any transaction whatsoever or about anything already written to the ledger. So in the TRIB might say, oh, now it's working. I don't want the TRIBs. Just give me the good stuff. There we go. So I can click on this and see exactly what it was and say, okay, someone wrote a schema that has an address, an ID number, and a phone number. The company's name was Evernim. And then the rest is just kind of metadata about that transaction. Now there's a bit of a naming clash here because they used to call it claims instead of credentials. So the authors of IndyScan haven't updated it yet, but that's what a claim def is. A cred def. They used to call them verifiable claims versus verifiable credentials. They found the name credential was a better. Okay, come on. But you can see, at least as of right now, there's about 50,000 transactions already written. And this is a pretty low writing network. It's mostly reads. Because think about, most issuers are not writing brand new schemas. They want to reuse existing ones for portability. Did you have a question, or are you just stretching? Yeah, go ahead. Sorry, what? So the question is there a way to link schemas from link outside data to a schema?
There is an existing ontology, and I would like to use it as a schema in Indy.
Right now we don't just link it, but you could just write it and say this came from here. Because the whole point is you don't want the schema to change. You don't want a pointer that says go here, because that reference could change the data itself, but the link itself would be permanently on the sovereign blockchain. So that's why we generally just say write the thing you want. Okay, there we go. So you can see there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different issuers right now on the live network. Most of this you don't care about because it's all cryptography. Let's see. Yeah, this is the block it was written in. This is the type. The version. Anything you want to look at, just use IndyScan to kind of look at things. So there's quite a few DIDs written on there. Anyway, that's what a sovereign, let's see, where's the DID? Anyway, yeah. Yep, there's your DID. It's base 58, similar to Bitcoin. Now if I switch to this one, it's probably going to be a lot shorter. In fact, it may not even be up. Yeah, because they rewipe this about every month. So if you want to just test out stuff and just flood it, go ahead. because then it'll be gone in a month. So this is a great place to do your testing and sandboxing. As you can see, there's not a whole lot because they just wiped it, and they're going to wipe it again in a week. So. Wow. Oh, Swisscom is now putting their stuff on there. Yay. This is a multi-signature, so. Does anybody have any topics that they would like me to cover and show them how to do while I'm still here? Yeah, go ahead. For payments? As in you want to be able to transfer value on the sovereign blockchain, is that what you're asking? Or okay, so if I understand your question, you want to be able to know how to send payments using Sovereign, right? Okay, so Sovereign does or will be supporting a token to send money back and forth. It was supposed to have gone a couple months ago, but we're still working on it. So there is a plan to put that in there, but it's mostly from a utility perspective, not from, hey, you know, it's going to go up to $8,000 a token, therefore it's the new Bitcoin, right? That's not the goal of it. But yeah, there's usually associated with a cost when you go to get a credential, like when you go to purchase or when you go to get a passport, right, you have to pay something for it. So yeah, there is plans to put that in there. I can cover what we currently do. It's not in the tutorial link, but I can show you where kind of the code is. So Hyperledger Indy is payment agnostic. So you can put your own, but it does support a plugin. I just typed in the wrong thing. I can show you where it does that from Indy SDK because it's probably easier. So the default payment so Indy supports what's called a payment handler. So the default is null, right? It does nothing. You put in something, it just returns nothing. But you can write your own, but you can take a look at libnullpay to write your own payment handlers. So if you want to do credit card payments, fine. If you want to do fiat of some other kind, fine. It doesn't care. Sovereign is doing its own kind of token just for the whole monetization effort to transfer value, if nothing else. So I don't normally cover that in the demo, but if you want that, that's where the code is it's right here in libnullpay, and you can take a look at how it works. But Indy Node also supports it, where you can put whatever you want. So I know Kiva, for example, is doing their own payment method, which is why they've deployed their own Indy network. So Sovereign has theirs. So people right now are doing their own kind of payment handlers. Is there any other topics that you wanted me to cover with Indy and how to develop verifiable credentials? Yeah, go ahead. Can I create a peer-to-peer connection? Is that what you're saying? On how to do that with DIDs? Are you wanting me to show you on a mobile phone? How to
business model for. It's a kind of machine-to-machine business model. Can you create a peer-to-peer connection between charging station and electric vehicle for their payment and connected?
You could do that with Aries, yeah.
Yeah.
I haven't ever done that with this, but you could, yes.
How can I create a system with the security base?
So you want to create a system to do these connections, is that what you're saying?
Yeah. Because we have a startup and we want to create independent system for every local regulation for the payment and any tax advantages. And we want to connect every vehicles to between for their payment and connection, kind of booking service and online payments as a kind of different share, market share system.
Yeah, so you could do that. There's some free apps that are available right now. One is called Street Cred, and then the other one is Connect.me. They both support that. Well, Connect.me already supports sovereign payments if that's what you want to do. I'm trying to bring it up on my phone, and man, the Wi-Fi is going slow. I could show you on my phone, but it's not connecting.
Can you suggest in IBM blockchain platform or Amazon blockchain service?
You talking about IBM's Fabric? The Fabric blockchain? I haven't ever used Fabric.
All right.
So
no, I don't.
I know they use I know Fabric uses their own anonymous credential system, but they're looking at moving to URSA to use the exact same thing for their proofs.
First, sorry for my primitive question. I couldn't recognize the difference between Indy, Aries, and URSA. When should I use one or the other? How to choose for which purpose?
Okay. So Aries, for example, is meant to be, I want to develop an agent, like on my phone or my laptop, something that is blockchain agnostic. It's kind of the place where the user goes to interact. That's where Aries lives. Or at least that's the goal of Aries.
Okay.
Indy is if I want to do ledger development, blockchain development, then I go to Indy.
Okay.
If I want to do cryptography at the lower level, that's what URSA is for. That's where I spend most of my time now.
Okay, it's clear now. What are those maturity levels? Are all of them are used by companies? How is the condition?
So URSA is used by Indy, Aroha, soon to be Sawtooth, and possibly Fabric. So if I go look at Indy SDK, for example, where is it? Hey, something in English. Come on, there we go. So Rust, for example, allows you to publish what's called a crate. And if this even comes up, you can see it's using URSA right there. It's just a dependency, and so it's just wrapping it under the hood. Aroha, for example, is written in C++, and they're just wrapping it because URSA exposes all of its functions through C. So that's how Aroha is doing it. Sawtooth is written in Rust, so they're doing the same thing that Indy does here. And then Fabric is written in Go, so they're writing a Go wrapper for URSA, for example. But if you want to do agents, which is where most people want to develop their stuff because that's what sells, right? You usually don't sell blockchain developers, you sell apps. So that's what you do with Aries. And Aries, if you want, was accepting a ton of contributors right now because the project's only a couple of months old. But it's getting a lot of attraction from like Ethereum folks, us obviously, and Intel, IBM. So does that clear up your question? Okay. I can't hear you. I think your microphone's off. There we go.
Okay. How can we get prepared for a Hyperledger developer? Do you suggest any books or any tutorials?
How to get started with being a Hyperledger developer? So let's see if I've still got this open. Hyperledger has, let's see if I can go to it. If you want to get started as a Hyperledger developer, you can typically pick a project, and then you can go to or chat.hyperledger.org. Let's see, I never go there because I use the app itself. Did I spell that? Oh, .log. Sweet. That's a new domain name. Not com, org. So typically each Hyperledger project will show you how to contribute and get started with them. So for example, if I go to Aries, they'll tell you where the meetings are, how to connect to those meetings, how to chat with the developers. Let's see. Okay, they don't, but I know Ursa does, because we did it the right way. So for example, in Ursa, let's see, oh yeah, so there's a contributing that says, join us on Rocket Chat. This is when we meet. Here's the link to meet. Here's some meeting notes. Anyway.
Okay.
Usually they have a contributing section, and then you can start watching and listening to it. But so that's not very exciting. So let me show you the one that I'm using. So you can go in here. There's Indy. There's Aries. There's Ursa. Anyway, and some other ones around there. I can search and see what else is up here. So I think there's some for Sawtooth. It'll come up. Yeah, so see there's some Sawtooth ones. Pick your project. I know Fabric has some. But chat.hyperledger.org is where you could start talking to developers directly. I know the Indy community is very active and very responsive. In fact, I almost think they predict the questions I'm going to ask in the future. So half the time when I think of a question, if I search, someone else already asked it and they already answered it. And they're trying to link a lot of those questions to Stack Overflow so it becomes searchable. Hey, there's Mike Herman right there. You can ignore that guy. So that's a great place to get started.
Thank you very much.
Any other questions or areas? Yeah.
I'm sorry if this question is not related with this session. Using this system, people, let's say, they are holding their all deeds and verifiable credentials on their device, let's say on their mobile device. If their phone is stolen or it's breached, then their identity is stolen. So in that case, does Sovereign has any extra security layer on people's private keys? And if that happens, if my private key is compromised, is there a way to recover my private key?
So yeah, we developed a protocol called DKMS, Decentralized Key Management System. And as part of that, I will show you a document. This is in the Ursa docs repo, but we typically don't put PDFs in GitHub. Git doesn't like PDFs because they're binary. But yeah, we have thought of a way that Sovereign doesn't specifically provide this. This is what Aries is for. It's for your wallet designers. Whoever designs your identity wallet would typically take care of that for you. But the idea is that on Sovereign we are going to have a thing called an authorization policy. And typically when someone installs the identity wallet on their phone, it authorizes that device, and you typically set up a recovery system so that if my phone is breached, I can actually disable the phone from my recovery systems. And even though the attacker has my phone and has my credentials, he still couldn't prove them. He couldn't use them to do proofs. It would lock it down.
Is there a central authority to provide that?
That the authorization policy is something we're putting into the ledger right now. So wallets that want to take advantage of it can do that. So that's coming within the next couple of months. That's something that a lot of people want. So like I said, if you want the actual crypto details and how it actually works, the technical details, you can go to Ursa Docs and look this up, what I'm about to show you. But it doesn't render, so you have to render it yourself. So I'm just doing this so it'll render it for me. Wow, it's taking a while. But yeah, the idea is that I have my phone, I have my laptop, I might have some offline USB device, and then if my phone is ever stolen, with my USB device and my laptop, I can disable my phone. Such that an attacker just having the phone by itself, he couldn't do the reverse. To me, that would be terrible, right? That's a terrible use case where he disables everything else and now has basically stolen all of my credentials. Now, that being said, if that were to happen, you could basically contact the issuers and have them revoke all of your credentials. And then those credentials are equally useless at that point. He can't use them. He can prove that he had them, but he can't prove that they're still valid. Yeah, if you want the full math, here it is. So here's the idea of the authorization policy, is that you can set up a threshold. So I have to have 3 out of 5 agents to revoke, or 3 out of 5 to provision a new one. Because what you don't want is for him to steal a phone and then provision a whole bunch of new ones and then lock you out. So you can set up however that is you want. Aries should do that for you. But the primitives on the sovereign ledger are there for you to take advantage of. Yes, it is. Like I said, it's in the, so if you go to GitHub, Hyperledger, docs. The same document, you can go read it and you can even render it because I provided the script when I wrote it. Let's see if it even loads. Let's see, is it here? A non-creds 2 is what we're calling this. And yeah, it's all in here, but this is LaTeX. So if you want to render the PDF, you just have to have Docker installed, and then you can run this, and it will make you a PDF, which is the same thing I showed you on the screen, which has this. But this is actually like the raw crypto and how it all works, and then the idea is that you have to not only prove that you have valid credentials, but you also have to prove that they're presenting from a valid device. And then if the device is not authorized, the verifier is expected to not trust the proofs. Now, as far as backup and recovery, there's 2 different ways you can do that, but that's, again, an Aries thing. You can back it up to any providers you want. Some of the DKMS protocols we designed basically say you could back up some of it in pieces, and then once you have 3 out of 5 or 4 out of 7, some threshold, right, then you get it all back. So that way you don't trust Dropbox by itself, but you might trust it with a piece of it, or Amazon's Drive, Google Drive, pick any Mozy, some other backup service provider of your choice. You can distribute it, and then assuming your phone drops in the toilet and you need to recover it, then get your new device, get your backups, and you're back up and running. There's also the idea of a social recovery. So when I provision my identity, I have people I trust that in a moment of crisis, I can ask them through software. Hopefully Aries will implement this. I have 10 recovery buddies, and then something bad happens. I dropped my laptop out of the car when I got out, or it got run over, whatever the case may be. And then automatically I say, I need to recover and then it goes out to your cloud agents and says, I need my recovery pieces. And they automatically respond to say, okay, we acknowledge it, but then, you know, I want to make sure it's really you asking to recover and not some attacker, because that's social engineering. We want to avoid that. So hopefully the wallet, and I know Evernym is designing this, and I think StreetCred is too, to do this automatically, that says call the person either through FaceTime or whatever to make sure it's really them, and if it is, then click OK to make sure it's them. So that actually offers an additional mode of authentication, because they have no proofs, right? They can't prove anything to you because they've lost their wallet. So, good question. Long answer, sorry. Any other questions? And how to get going and get started with verifiable credential development. Now, if you don't want to use ZKPs, you don't have to, but with Indy, we recommend it, because of the privacy and the portability it offers. So, anything else? Or are you all hungry and ready to go? Yes. Yeah. It's right here. So if I could, let's see if it'll let me do it. That's too big. Let me go smaller. Oh, there we go. Let's see if I've already got it. I can show you how to just read the PDF on your local machine, so you don't have to do what I just did. Let's see how long this takes. The idea is once it's in final draft, we'll just publish the PDF and you can download it. But we're still making minor tweaks and revisions. It's probably like 90% done. It's mostly just being reviewed by some cryptographers, which is why we've still left it in draft form. They're mostly okay with the primitives that we were using. They're just double checking our math to make sure we have all the math right. Maybe I should tether to my phone. I can't believe how slow that is. Is everybody's internet running this slow, or is it just me? It's just me? Oh. It's slow for everyone? Okay. All right, we're going to do this. Where's my phone? Come on. Quick, everybody connect to Mike's phone. yours? Is it showing up?
If you check from your Wi-Fi. Check your Wi-Fi.
Oh, it finally connected to my phone. Or maybe. Oh, now it hopped off.
Can you try
Is
to
it that one?
spell mine? Its name is. Can you show it? Yeah. Maybe you can.
Which one?
Yeah, the last one. The last one. Yeah, let's try that. And this is the password.
Did it connect?
No.
I think it did. No, it didn't. Well, did I type wrong? Did I type it right?
No. It's incorrect.
Okay, nobody look.
No, you can. I'm gonna change it. Don't worry. Because two. You have to put a 2 after something. Yeah. Try.
It doesn't like my Turkey Wi-Fi, I guess.
Nothing happening.
Nothing.
Maybe you can stop and start it again.
Oh, maybe. Maybe.
Probably the phone
Let's
is
do
on
this.
variable.
Let's do this. I don't want the whole repo, I just want one. Let's see if it'll let me do a shallow clone.
There's an issue.
Yeah. That's a bummer.
Let's just give up. Don't do it.
Yeah. Well, thank you for coming, everybody. And let me know if you have any other questions. I'll be up here, and I will also be available tomorrow if you have any other questions in terms of any development. Sorry the Wi-Fi is so terrible, but thank you for coming, and hope you enjoy your dinner.